In this video, I want to have a look at graphs that represent how something is changing over time. So for example, this first graph that we're going to look at here is looking at how noise level changes over time. And the context that we're going to give this is that it's in a classroom over one lesson. So if we were to describe what's happening here, we could say that it was right down at zero, the noise level, before anybody entered the room. As students entered the room, the noise level increased to its maximum. And then we started teaching, the students started working, that noise level dropped down. It did pick up in the middle of the lesson. Maybe there was a class discussion, maybe students were just getting off task. And then maybe that discussion or activity finished, or the teacher said something to the class about that the noise level was getting too high and it dropped back down. And then maybe it peaked again as students were packing up, and then it's dropped right back down to zero as the students are leaving. So this is representing the noise level over time, and we can make judgments about what was happening over that time based on how that graph is changing. So I just want to have a look at these four graphs now and match them to these four statements. So just remembering that the speed of an object that's moving is represented by how steep our line is. So the steeper the line, the faster the object is moving. So for example, if we look at graph A, that line is getting steeper and steeper as we move along. So it's slower at the start and then it's speeding up as we move across. So if we have a look at these four here, it would match this third one that says P increases slowly at first and then more quickly because the graph is getting steeper. So this one here would match graph A. If we have a look at this one instead, the line is quite steep and then it flattens out as it gets towards the top. So that means it was going quickly and then it's slowing down as we move across. So that would be this one here. P increases quickly at first and then more slowly. So that would match graph B. Now these ones are slightly more complicated. So in this one, we've got it quite steep and then flattening out and then getting steeper again. So that means it's going quickly, it's slowing down, and then it's speeding up again. So that would be this one here. It increases quickly at first, then more slowly, and then quickly again, which means that this one should be D, but let's just double check it. So it's quite flat, and then it gets steeper, so it gets faster, and then it slows back down again. So it increases slowly at first, then more quickly, and then slowly again. The last example I want us to think about is if we had some sort of flask or beaker from science, for example, and we're filling it with water. So the water is pouring in at a constant rate, and we want to have a look at how the height of the water, or the water level, is changing over time. So we know that it's going to be increasing the whole time because we're pouring water in, but it's going to change. So if we had, for example, a tall, skinny flask compared to a really wide flask, then if we're pouring water in at the same time, this one would fill up much more quickly than this one would. So the skinnier the section of our flask that's changing size, the faster the water is going to be increasing, the water level is going to be increasing. If we have a look at our flask, it starts here where it is a bit skinnier and then it gets wider. So that means it's going to start increasing quite quickly, but it's going to slow down. And then we've got this bit that's almost straight, so it's going to sort of sit at that level for a little while. But then it's coming back in. So that means it's going to get skinnier and skinnier. The water level is going to rise faster and faster. So we're going to increase that. So that's increasing as that line gets steeper. And then once it hits this bit, it's going to increase at a constant rate now because it's going to stay at a constant width. So that means from this section here, we're going to have a straight line from then on until we reach the top of our flask. All right, so that's having a look at a few different examples of graphs that represent change.